Okay, so this is to 5 solving equations using square roots and cubes. They are wanting us to create an equation. So basically, they want side lengths of 4 inches. So I know that there's some equations that they want, and I could get all complicated, but I don't really want to or need to. So I'm going to set this up as x, which is my volume, will equal 8 cubes times 8 cubes times 8 cubes, because it's length times width times height. And I got that because I did 4 times 2. Now, why I did 4 times 2 instead of 4 times 1/2, I know that every inch requires 2 1/2 pieces to get there. So I tried to make these, but like if you can picture each one of those being an inch, you'd need 2 of them to get 1 inch. So then x equals 8 to the third power. X equals, and I'm going to break this into 64 times 8 because I don't have that one memorized. I may again, but just so that we know. So 32, 48, 512. So x equals 512 cubes. So there is the work for that. We are going to continue to work on the rest of them. How can you solve equations with squares and cubes? So if they have a perfect square, you just like I did with the example. Darius is restoring a square tabletop. He wants to finish the outside edges with a piece of decorative molding. What total length of molding will Darius need? So I need to find out, and they're calling it S, which is exactly what I did. What is S? Well, since S is exactly the same because it says it is a square, which means that they are all the same. So this is exactly what they did in their step. I know that the area comes from it being squared, length times width. So like they did on this, they set it up A equals S squared. Well, we know the area because it shows it over here. So area equals x squared. The inverse operation of squaring is square rooting. So therefore, that's what they did. The next step was to take the square root of both sides, and then you end up with s equals plus positive or negative 5. Now, we have discussed on why it's positive and negative, but it shows you, again, over here, a negative times a negative will equal a positive, and a positive times a positive will equal a positive. But since we are talking about a side, that means general, I knew that it needed to be positive. So in general, this is what we're supposed to generalize. An equation of the form x squared equals p, where p is a positive rational number, has 2 solutions. The key thing that you need to remember that may pop up on a test, p has to be a positive rational number. So you cannot, at this point, take the square root of a negative number. We're going to hit pause. You guys are going to do this, try it, and then you're going to come back. We should have discussed this in class, but same thing, a equals x squared, s squared. So now I can put that 100 in here. I'm going to take the square root of both sides as the inverse. 10 is the square root of s, so each measures 10 meters. That convinced me, why are there 2 possible solutions to the equation s squared equals 100? So explain why only one of the solutions is valid. S squared can be a positive times a positive, or S squared could be a negative times a negative. This is a distance problem, so it must be positive. So this kind of works the same way. Kyle has a large cubed-shaped terrarium. Make sure that you pay attention to whether it's a cube-shaped terrarium versus a rectangular prism, or if it is not specified. He wants to cover the opening with a square screen. What are the dimensions S for the screen? So again, it gives us our volume, so they have substituted in for volume, but we do not know S. We're going to take the cube root of both sides in order to solve, and the cube root of 343 is 7. And again, it has to be positive 7 because it is a distance. We're going to do a practice down here. X to the third equals 64. So I'm going to rewrite it. You guys should try this on your own, come back and check, but I'm hoping we get this. So I'm assuming that you've came back, you've seen my work. Please make sure that you remember to specify that it's the third root. If you leave that out, then it is the second root, so that, or the squared root. So x will equal 4. And it could be positive or negative 4. So if you forgot that step, make sure that you put the positive or negative in there. Example 3, solve equations involving imperfect squares in cube. What it's showing you here is you do not have to actually solve for a number. You just leave it in the, I think that's called a radicand. Leave it in there under the radicand if it's not perfect. But you do have to put the plus and minus in front of it. So I'm going to show you these just to make sure. So I'm going to rewrite this as a to the third equals 11. I know that 11 is not a perfect cube, so I'm going to take the cubed root of a to the third equals the cubed root of 11, and I'm allowed to leave it as a equals plus or minus the cubed root of 11. So this is your final answer. Notice that the positive and negative is in front of it. That must be left that way. Same thing over here. I'm going to rewrite it. C squared equals 27. I'm going to take the square root of both sides. Notice that I am not putting the little number here because this is an understood, it is the square root. So C will then equal the square root of 27, but it must be plus or minus. So make sure you do not forget the plus or minus. We are going to work together on the key concept and the do you understand and do know how, but we will probably be working on the other page as well.